Now that you've learned some basic matrix operations and kind of have a better understanding of what a matrix is, now we're going to discuss some special matrices called the identity matrix and the inverse matrix. Now, if you recall from just basic mathematics, that whenever you multiply anything times 1, it just equals itself. And that's basically what the identity matrix is. It's like multiplying something times 1. So if I multiplied a matrix times the identity matrix, I would just end up getting the original matrix and from that multiplication process. The other thing that happens is that you also know that if you multiply two matrices together, or two numbers together, and equal it to 1, that those two numbers are inverses of each other. So the same situation applies here as well. If I multiply two matrices together and get the identity matrix, then I know that they are inverses of each other. So let's just take a look at that from just a numerical sense. You can see here I have 2 times 1/2, and it equals to 1. So what I know about the 2 and the 1/2 is that they must be inverses of each other. Now, generally speaking, most people tend to think of the 1/2 as the reciprocal, but its true definition is the multiplicative inverse of 2. And so we get the 1. So basically that's the same thing that would happen with two matrices. If two matrices were multiplied to each other, they would end up equaling the identity matrix. We would know that they're inverses of each other. Now the way we represent a matrix inverse is through this use of the -1 exponent. So you may have seen this before in other parts of math. So say x to the -1. If you remember your exponent properties, that means 1 over x to the first power. So that's the inverse of x. And so we can see that x times 1 over x equals to 1. Or we can write that in inverse form, x times x to the -1 power. That's still going to equal to 1. So we use this -1 notation as this exponent to imply inverse. And so I don't want you to think that you have to do some sort of operation with the exponent in this particular case with the matrices. That's just a notation example. Okay, so let's go back to the notes. And so now we can see that we have the identity matrix and the inverse matrix. Now this has to take place in a square matrix, 2 by 2, 3 by 3, 4 by 4, so on. And of course with our multiplication rules we have to make sure our row and columns match up. So what you're generally going to see here is anytime you're working with identity matrices and inverse matrices, they're going to have the same row and column dimensions as the original matrix. So that makes things a little bit easier. Keep in mind that you also have your calculator that does these for you. Now at some point during class you're going to be made to learn how to solve multiply a matrix by hand, and we'll go over that in class in a little more detail. Now a new definition here that you're going to see is something called a determinant. Now determinant is associated with the square matrix, and we'll show you how to calculate that by hand as well. But your calculator will do a determinant also. Basically what we do with the determinant is it's part of our inverse calculation. And so it lets us know if we solve the determinant, we can tell whether a matrix has an inverse or not by understanding what that determinant is. Now, if that determinant is equal to 0, then the matrix does not have an inverse, and you'll understand that a little bit better when we show you the manual calculation of an inverse to come later in class. Now, if the determinant is not equal to 0, it can be equal to any other number, then that matrix has an inverse. And so basically what I'm going to do here, and since you haven't had the opportunity to see this on your calculator yet, I'm going to show you the first one, part A, and then I'm going to ask you to do part B and C on your own. For sample problem 1, it asks us to use the calculator to complete the matrix operation. So it says find the inverse of A and calculate the determinant first to see if it has that. So we're going to take the determinant. Let's show you how to do that on the calculator. So if I come to my calculator, I go to calculators. If I go to menu, and you can see that our menu actually has a matrix option. The third matrix option is a determinant. So what I'm going to now do is I need to put the determinant of the given matrix. And so you remember the matrix template that we had, and we're working with the 2 by 2 matrix. So I'm going to pick a 2 by 2 matrix. Try to. And then I'm going to put in those numbers. So 3. And then I can see that my determinant of this matrix is 2. Now let's go ahead and put that in our. So what the notation for a determinant, it looks like an absolute value symbol. But since we're dealing with a capital letter here representing a matrix, that's showing us that it's a determinant. So the determinant of this one, of part A, is equal to 2. That tells us that we have an inverse to this matrix. So I'm going to go ahead and find the inverse of this matrix, again using my calculator. So let's do this. We're going to go ahead and put the matrix in. Now that I've got this matrix in here, the nice thing about the -1 notation is that your calculator recognizes anything raised to the -1 as an inverse. And this makes this calculation very easy. So I'm going to actually raise this to the -1 power and hit enter. And it's going to give us the inverse of this particular matrix, which is what we were looking for. So I'm going to go ahead and fill that in as well. So that's a quick way to use your calculator to find the determinant of a matrix and to find the inverse of a matrix. So go ahead and do parts B and C, and then come back and check your answers. And you're more than welcome to use your calculator. Again, we're going to show you how to do these by hand in class, and we'll discuss when you might need to use that. I've gone ahead and filled in the answers for part B and C, so check your answers against mine and see how you did. Alright, that's a good introduction to identity matrix and inverse matrix, and we'll continue with the notes in the next video.